me folks, we continue here at the IFFA show. This is day 3, and we were walking by and found a very interesting equipment that it's one of those things when you find an equipment or a technology that has a scientific background that is unique, that it's easy to prove that it works, and they have the data. So before we talk about the equipment, we want to introduce Piotr and Michał from Bsharp from Poland. How are you?
Fine, thanks. Great.
Maybe you guys can start and introduce. This is a sharpening technology that has a lot of benefits for the meat industry, and it's a fairly new equipment out there, and they're launching. Maybe you can explain how this started, how this project started. Piotr has a PhD in engineering.
Yeah.
They're cousins as well, so I just before recording we were asking. So please.
Yeah, so it all started with knife production. My uncle and Michael's father started more than 40 years ago to produce butcher knives. And when Michael came up to the business, many of our clients said that the quality of our knives is poor, and they came up to us with some problems. And then when we focused on what caused these problems, in most cases it was wrong sharpening procedures. Often the tip of the blade was overheated, or for example the roughness of the tip of the blade was too big, and this all created the bad view on our product, on our knives. So we wanted to give a solution to our clients which will first solve the problem of the sharpening, and secondly will improve the overall experience with our knives. Because we knew that our knives are good products, but if you sharpen them not in the proper way, if you do some mistakes, then you may think that the knife is not as good as it is in reality. As you said, I'm also a scientist, and we established an R&D project 6.5 years ago. It was the main aims was first to get better understanding of the cutting process and how the cutting edge becomes dull. So we wanted to create a method to assess the sharpness. We call it initial sharpness, so actual sharpness in one moment, but also to get better understanding how the sharpening process, the sharpening angle, and all the aspects about the sharpening influences how long the knife will stay sharp, because it's the most important thing. Not just how sharp you can make it for a second, just how sharp it will be throughout, for example, 8 hours or 4 hours. So between consecutive sharpening, you want to have the best overall sharpness. So it was the first aim of the project, and the second aim was, if we understand these processes, then we will try to find new, better solution to sharpen the knives. And also our aim was to create the sharpening system, the set of devices that will be as possible simple and can be applied in meat industry, poultry industry, fish industry, and so on and so on, because we also knew that the specific needs of the industry. Within this project, we created something that is called WR tester, from wear resistance tester. You can find a video presentation about it, and I also showed you a scientific article about this device. This is a completely unique machine. It takes a knife and it does 120 consecutive cuts of a special medium. This medium was also designed by us because we wanted to have something that will replicate the cutting process of meat because other devices that are designed to test the knife sharpness use something like a mesh or some cardboard or something like this. And we knew that the cutting of cardboard is completely different process from the cutting of meat. So we designed specific medium. We cut this medium using the trajectory that is similar to the trajectory of human's hand, and then we measure forces and torques created during the cutting process. We do it 120 times. There is a specific silica powder in the medium to make the tip of the knife dull a bit, and then we monitor the increase of the overall forces and torques, how they increase during the 120 consecutive cuts. So then we had a tool to assess the sharpening process, not only by the mean of the initial sharpness just after the sharpening, but we can test the, we call it edge retention, so how long the knife will stay sharp. So that was like the main...
That's the main goal.
Yeah.
And and it's amazing how you had an issue, like a need in the market, your uncle selling knives, and then you come up with this, and going back and say, hey, now that with this machine, your knives are gonna last longer, so ultimately less knife sales, right? But they last longer, but it's a real solution for the meat industry, for the food industry, right?
And moreover, with the WR tester, we are able to compare the steel grades, and we know now that it's worth pay more for the steel because we get much better results and much better edge retention. And as Peter mentioned, there are some testing machines, but all of them are focused on initial sharpness. So how sharp is the knife straight after sharpening? But in our opinion, much more important is edge retention or wear resistance.
Right.
Because workers are using this knife for a couple of hours during the shift. So we wanted to know what is after half an hour, what happens after 1 hour with the knife. So that's why we created WR tester.
And right now we see that throughout like last 5 years there's a growing number of scientific papers and institutions who focus on like how to get the workers the best tools we could to reduce the risk of musculoskeletal disorders, which in this group is like a huge problem. And it's all over the world. In New Zealand, for example, there's somehow famous company Anago also creates the machines to test the sharpness, and in the United States and so on and so on. So right now we see that this problem is somehow getting bigger and bigger, and more people are somehow interested to get the objective measure of the quality of knives and the quality of sharpening, and like see that it's really crucial when you like care about the effectiveness and the safety of the stuff. So this is like the first part, because then we had a tool by which we can compare different tools, different methods of tooling, different sharpening strategies, or thinning strategies, or honing strategies, or polishing strategies. So it was like the first milestone. We can measure what we do, we can assess if we are moving forward or it was a step backwards. And then we know that what is the aim? The aim is to have the best edge retention for, let's say, so to make your knife stay as sharp as possible for as long as possible. We also know that it's crucial to make the sharpening process as easy and as fast as possible, because of course knife can be sharp in many ways, and it can be done good, but it takes it requires a lot of experience and it takes a lot of time. You can sharpen a knife with a stone, you get really good results. There are a lot of YouTubers and channels who focus on specific chef knives and so on, or sushi knives, and they show you that, for example, with a set of Japanese stones you are able to get excellent sharpness. Still, it takes 1 hour per knife, and for meat industry it's impossible to apply such
it's not such solution. Kind of sharpening competition. It's real life in a real meat plant, so that's why we are focused on it, not on like the best.
And we knew that our clients, some of our big clients, sharpen, for example, more than 1,000 knives per day. So we had to give them the solution, which will be fast, reliable, will not require huge experience, knowledge, and physical abilities from the staff, and still will
good results. Anyone can use the machine. Anyone can, no skill set whatsoever needed.
Exactly.
That's amazing. Tell us about the CBN. I think I before recording that was part of the value added of this machine.
So with our WR tester, we were able to test as I said, different processes, and the first let's say part or the first aspect of our sharpening system was to find the best tools. Because the knives are made from hardened steels that has the hardness of around starting from 55 to 60 IHRC in a Rockwell scale. It is a hardened steel. You have to use specific tools. When you look at let's say best types of tools, which are called super abrasives, you have diamond and something called CBN. The abbreviation is CBN. It is cubic boron nitride. It's the second hardest material next to the diamond. You cannot use diamond tools to grind carbon steels, which are made which knives are made of, due to the fact that you have a carbon also with the knife steel, and there's some migration with the materials, and you get increased tool degradation, and it's also not good for the knife itself. So we looked at the possibilities with the CBN. Unfortunately, our process is specific because we want to do 3 steps in 1 step. We want to do the thinning of the tip, we want to do the sharpening and the honing. In most of our competition they have 3 or 4 steps, as I said. But we want, we asked ourselves, okay, can we find a specific mixture of different meshes of the CBN grain, and then create a tool which enables you to do all these 3 steps in 1 step. This unfortunately required for us to create our own galvanic line to create our tools, but we managed to create a tool design in which with 1 pass you do these 3 steps and only polishing is needed. Even for some our clients who are beef producers, they do not polish their knives, because for red meat you sometimes not you do not require this perfect, let's say, smooth sharpness. However, our finding is you have to polish. There's a final step you have to polish somehow. So we have only 2 steps. All of the steps of the sharpening is with our machine, with our specific tool design, and then you only polish the tip of the blade. And with the CBN tools, we also have a unique MQL cooling system, which stands for minimum quantity liquid system. We basically create a water mist, which is much more effective in cooling. It also makes the sharpening area better. It ensures better visibility of the sharpening area. Instead, when you pour a lot of water, then it somehow blurs out the sharpening point. And it also uses less water. So we have 3 advantages from the system. It's completely unique for our sharpening system. But still, it also works really good with the CBN. So what we had right now, we had 3 steps in one step, and we have a technology which is somehow like burn-free. There is no risk of overheating the tip of the blade, which is often like one of the biggest problems.
Yeah.
If you use a belt sharpener,
You lose the temper of the knife.
yeah, and then you basically ruin the knife. Even if you resharpen it, you have to do it multiple times to like remove the material but lost its hardness. So that was like the start, and then we analyzed like what also had huge influence of the sharpness and on how the final user feels about the sharpness. And of course, crucial thing is the sharpening angle. Unfortunately, there is no such a thing as optimal sharpening angle for all procedures and for all like purposes and for medium. So we had to develop the electronic control system, which will enable to easily adjust the sharpening angle. And we created the specific type of a control system, which gives you the possibility with just few clicks, you set the angle. And it ensures that it will be always constant. And it was possible due to the fact that the CBN tools has constant diameter, because with the wear of the tool, you do not observe a decrease in the diameter. If you use conventional tools, then the diameter of the tool decreases with the wear of the tool. Also, each more or less 4 or 6 hours, you have to do the redressing. With a diamond, you have to do the redressing somehow to make the tool more smooth.
Yeah.
And then you decrease the diameter even more, and then you have to recalculate what is the actual distance to ensure that, for example, if you want the sharpening angle 30 degrees, and you sharpen, for example, 50 knives, then you have to readjust your machine. You do the measurement of the tool diameter and so on and so on.
So a lot of time that it's consumed by doing that.
Exactly. And to be true, to ensure the constant angle, the slight adjustment should be made after each knife. It's impossible. With our tools, the difference in diameter between the new tool and the tool that is finished, worn out, is less than 1/10 of a millimeter. So the precision in the angle setting system is really good. And when we have this specific CBN tools and this angle adjustment system, then we ensure that each time, if you set the angle once, with each consecutive sharpening, you can remove the least possible amount of material to get your edge sharp one more time. And thanks to this, you do only one pass for a knife like this, which is somehow one of the most popular knife designs, 15 centimeter boning knife. It takes more or less 6 to 8 seconds to resharpen a knife like this, and it removes the least possible amount of material to just get the new sharpened tip of the knife.
Thanks to that, there's huge reduction of knife usage by 40%. So
somehow it is like as a knife producer, for us it's not maybe so beneficial.
We didn't expect such a big number, but
we were not aware basically of the fact that when you use a belt sharpener or some
traditional
methods,
sharpening methods.
You do multiple passes just to be sure that you reach the tip.
Yeah.
And you basically destroy your knife.
Yeah. You're grinding. It's more aggressive on the blade.
It's much more aggressive. It's much more aggressive. What we do is just basically maybe not only honing, but it's just really delicate grinding of the tip of the blade, because the angle is set, it's constant. We remove only the
what's
smallest
needed.
possible, because we also did the test with electron microscope, what is a dull knife? What is the radius of this like dull tip of a knife? And in the meat industry, the workers said the knife is dull when you have 9 micrometers diameter of around the tip. They say it's dull. Maybe, for example, me or my wife will say it's still sharp, but they require really good sharpness. And with this, you only need to remove more or less 5 micrometer on each side to get new tip and to have perfect sharpness. So there's no need to remove more than this.
And that's where the 40% comes,
Exactly.
because by grinding less, by passing it less than the traditional method, sharpening methods, you just basically increasing the lifetime of a knife, and ultimately for the producer, for a meat processor, that ultimately translates into saving money, right?
Exactly.
I would like to see the machine running, for people to see, like, we're not talking about some alien or some it's a simple machine that anyone can use it, and I would like to show them that.
Just one more thing, like the savings are not only from the reduction of the knife usage, but also due to the fact that you only one pass, you can do the sharpening much faster with this machine.
Yeah.
You do not do 4 steps or 5 steps. You can do it with a stone, but it will take half an hour. And it's only to do 1 step when polishing, so you reduce the burden, you reduce the knife usage, and you get like repeatable, very good result that can also be beneficial for the overall efficiency of the whole like plant.
It's also worth mentioning that it doesn't require skilled staff, because you need to have like 15 minutes practice to learn how to
Operate it.
Yeah, properly. So you don't need like qualified staff. Sharpening process takes around 8 seconds in case of like typical boning knife. And yeah, so the knife reduction drops by around 40%, and there is no chance, no possibility of overheating the blade, which simply demolish and destroy the blade.
Nice. Well, thank you very much. Let's if you guys will be more than welcome to.